All right, guys. So this section is probably the most applicable part of exponential functions. So we're going to talk about growth and decay rates. And so if we're talking about the form of exponential, so a times b to the x, anytime we're talking about growth and decay, we have to start with something. So we have to start with an a value, and remember that's our y-intercept. That a value has to be positive because we have to either increase or decrease some value. We can't increase or decrease negative. So when I mean value, we're going to be talking about like real world situations. So if that b, remember that's your common ratio. If that b value is greater than 1, then we're going to call that function as growing or increasing. No, I can't spell growing. So that means our values are going to be getting bigger as our time or our x value increases. Now, if that b value is between 0 and 1, either a decimal or a fraction, a lot of the times here we're going to be looking at decimals because we're going to be dealing with percentages and money, and we don't usually look at those in forms of fractions. Then that function is going to be called decaying or decreasing. So what are some examples of exponential growth? So exponential growth could be money in an account where you get interest. And then what's an example of exponential decay? All of you have never purchased a car before, but when you purchase a car, as soon as you drive it off the lot, it goes down in value. So depreciating is another word for decreasing in money specifically. Let's see if I can spell this. Depreciating car value. And that value is going to go down at a specific rate over time. So let's read this function. So it says, consider the exponential function f of x equals 500 times 1.05x. That's kind of where I was talking about. We're going to be dealing with a lot of decimals on this one. This models the amount of money in Tyler's savings account, where x represents the number of years since Tyler has invested the money. So 500 and 1.05 to the x, and x is representing years. So the first question is the amount of money growing or decaying? Well, we want to look at the b value. It is bigger than 1. So we are going to say that this amount is going to be growing. What is the rate of growth or decay? Now, we need to decide what is the difference between that number, that b value, and 1, because 1 is going to keep it unchanging. How is that different than 1? So we want to take that value, 1.05, and subtract 1 whole, because that 1 whole is going to be like if that value stays the same. And that would be 0.05, but remember we're going to talk about percentages. And if we change that decimal to a percent, that would be a 5% growth. And we can see that just from the 1.05 itself. What does the 500 represent? That would be our y value. That's also going to be called our initial value. In this case, it's going to be the initial amount Tyler has in the account. So initial money in account. And then this says, if we substitute an 8 in, so that means after 8 years, if we did this on our calculator, we would take 1.05 to the 8th power times 500, and we get this very long decimal. And that is the correct decimal, but why would that not be an appropriate answer? Well, we're talking about money, and we in America measure money to the hundredth place. So although that's the right decimal, we want to round that to the hundredth. So if you were to give an answer for that, I would say 738.73, because that 7 is going to make that decimal go up to a 3. So after 8 years, he's going to have $738.73. All right, let's look at another problem. So this says, consider the exponential function f of x equals 21,000 times 0.91 to the x power, which models the value of Robert's car, where x represents the number of years since he purchased the car. So is the value of Robert's car increasing or decreasing, or growing or decaying? So we want to look at the b value, and we want to see, is the b value less than 1? Well, it is. 0.91 is less than 1. So we're going to say that it's decaying. And if we just think about the situation, he bought a car, and if we're talking about years since he bought the car, the value of the car is going to be less. What is the rate of growth or decay? Again, we're trying to figure out the difference between 1 and this number. So if we take 1 and subtract 0.91, that is going to be 0.09 or 9%. So it's decaying at a rate of 9%. I want you to be careful here. It's not decaying at a rate of 91%. It's decaying at a 1 minus that, which would be 9%. And then the last question for this, or the last part of this question, what does 21,000 represent? Well, that's the initial value, or that's how much he paid for the car, or the initial amount of the car. So how much he paid for the car. All right, so let's look at the next one. Number 3, here's another exponential function, 1,250 times 1.08 to the x power, which models the amount of money invested in a bond fund, where x represents the number of years since the money was invested. So this is an investment. Hopefully your money would be increasing. So if we want to figure out if there's growth or decay, we're going to look at the b value. It is bigger than 1, so it is a growth. And specifically, what is the growth? Well, the difference between this number and 1 would be 0.08, or you could also say 8%. I usually talk in percentages here and not decimals, but either one is fine. What does the 1250 represent? That's the initial money in the account. All right, let's look at another one. Number 4 says, consider the exponential function 25,000 times 0.88x, which models the amount of money remaining in Lola's retirement fund, where x represents the number of years since Lola began withdrawing the money. So she's taking out money, so that's why this value is less than 1, so that is going to be decay. And what is that rate of decay? Now, again, this is where we want to be careful. It is not 88%. We want to take 1 minus that 88, which would be 0.12. And that is also the same as that 12%. And then the other question is, what does the 25,000 represent? That's the initial amount of money in the account. All right, let's look at one more question. The equation 250 times 1.04 to the x models, what is it, growth or decay? Well, 1.04 is bigger than 1, so it's going to be growth. And the rate of growth here, 1.04 minus that 1 would give us a growth rate of 4%. Because we want to know the difference between 1 and that number. All right, last one. The function 350 times 0.75 to the x models the amount of money remaining in Alicia's summer budget, where x represents the number of weeks since summer began. Which of the following are true statements? The function models exponential decay. That is true because that number is less than 1. 350 represents the amount of money Alicia had in the budget at the beginning of the summer. That's also true because that's their initial value. The rate of decay is 25%. Well, if we take 1 and subtract that number, that would be 0.25, which would be 25%. I agree. And then the last 2 questions, we are going to need a calculator. I'll set it up for you, and then I'll substitute it in my calculator. Okay, so let's see how we plug this in the calculator so that we can do those last 2 questions. So we want to know after the first week. So we're going to plug in, 350 times 0.75 to the first power. So obviously anything to the first power is itself. So 0.75 times 350 would be 262.50. So, which is the number that they're giving, but it's asking that if that represents the amount she spent during the first week, and that's not. That's the amount of money she has left after the first week. So that fourth one is not correct. And then the last one is asking at the second week. So instead of our x value being 1, we want that x value to be 2. So we want to raise 0.75 to the second power. So let's clear this out, 0.75. And then on the calculator on my computer, I have to the second power, so it squares it. And then we want to multiply that answer times that 350. And that is 196.88 if we were to round. Remember, we're talking about money. So at the end of the second week, Alicia will have less than $200 in the budget. And that is true because she's going to have a little bit, almost $197. So that last one is going to be true. All right, that's it for this video. Again, let me know in Remind or email if you have any questions. Bye, guys.